My name is Iria. I'm at Die Mobiliar, the recently formed art analytics team. And I come here as in my role of industry practitioner, presenting to you what I hope to be an interesting case of application of machine learning and text mining in a use case at the Mobiliar for reinsurance of pension funds. So I'm not going to be telling you a lot about contribution to the field, but rather expecting to get some feedback from the more technical people in the audience about what we're doing and how we can be doing it better. Okay, so I'll start by some context, try to set the context for this use case in life reinsurance, and then I go a little bit deeper into the actual problem, which is we cast it as an information extraction problem. And then I'll show you a diagram of what we find to be the elements of a comprehensive solution for this. And then I'll go into 3 classes of open problems that we would like to get some feedback from you guys. All right, so Mobiliar does reinsure some products in the market. Basically, if you work for a company, your company will have the regulations about what happens if you get an invalidity or in case of death, what happens to your family and so on. These are all outlined in the berufliche Vorsorge documents, so the occupational pension funds regulations. And basically, Mobiliar, what they do is they reinsure to Swiss companies. In doing so, up to 30 Mobiliar employees can be involved in this process. Basically, there's a contact with the company, pension fund regulation comes in, there's a lot of people reading that over and over, determining what are the interpretations and the right parameters to lead to an offer in the end to the company. And several hundreds of such offers are made per year. And recently the market has become more and more difficult, and because of that Mobiliar wants to essentially try to remain competitive, and for that they're looking to text mining as a means to gain operational efficiencies and try to increase the throughput of offers per year basically. So in order to do that, what we have in mind is essentially take humans from their current role of reading and interpreting the documents to a role of basically looking at an already extracted version of these documents and approving that extraction. The documents are fairly complex. They range from, they on average have like 30 pages size. They range from small annexes of 5 pages to up to 50 pages total size. And basically, from one document, you can actually make several offers. A specific example is, for example, if you want to reinsure normal employees and then you want to have a different kind of conditions for travel. And obviously, you can have one offering also taken out from several documents. So it's an end-to-end relationship. In terms of languages, it's mostly German, 60% I'd say, with some French, 35%, and then you do have other languages like English and Italian there. And in terms of sort of complexity or effort, we're talking about 56 different fields that are required to be extracted from these documents. Stuff like retirement age, degree of occupation of the person, waiting period before there is some premium exemption, so when you stop paying premiums to your employer if you get in case of invalidity. The share that your partner gets in case you die, the share that your children get in case you become invalid, and so on. And so I'm showing here an actual text page from one of these documents, and the the actual form that people nowadays still fill out manually, and several people have to go through the same documents to make sure they are producing the right offer. And essentially the goal is to automate this process, right? The information does end up in a database at the end through the use of an internal application, but they still keep these forms. So everything is a bit redundant, and there's operational efficiencies to be gained not only in a text mining solution but elsewhere as well. Anyway, I wanted to basically go through the elements of such a solution. As you see, I'm not deep diving in anything, and this is fairly standard kind of pipeline. And there's several problems along this pipeline that I would like to discuss with you, and we'll do so in the next slides. But basically, we start with the corpus of documents that I was telling you about, the occupational pension fund regulations, and about half of them have to be OCR, and then we go through a shallow NLP pipeline, a very standard thing, first with a language detector, then a tokenizer, then a split lematizer, part of speech tagger, and limited recognizer. After that, we basically have to find segments or zones in the documents, which we then feed into a table extractor in case we're talking about a table there, or to entity extractors that can be rule-based or machine learning-based. We have both versions at the moment. Depending on the kind of field, it's more economical to write rules or to just train and classify. And then a relation extractor, and out of that, basically, we are preparing to write the database with the entity. This is a database that actually already exists, and I'm actually going to show you the status quo. So this database has about 1,500 past offers in there, which we try to start using as label data for training our classifier. We have custom built a UI tool that we plan to have the users use in their daily work, which includes some annotation functionality in it. With that, we get the labels for our machine learning-based entity extractor, which we currently implement very simply with just some SVM or some logistic regression. And basically, throughout all this pipeline, we're using open source tools. So for the OCR, we use Tesseract, which basically takes the majority of documents are PDF, and Stanford Core NLP for the NLP pipeline, some heuristics for the segmentation of the document, and then a component of Stanford Core NLP called tokens regex for the rules engine. Read SVM will call Abbott for the machine learning models. And these two components here we still haven't started addressing yet for time reasons. So I hope that this kind of, for the more technical of you, paints a picture of the kind of system we're talking about here. And our idea is basically to come here and ask advice, since this is the open problem session, about whether we could do something better here. So I will tell you about the problems we have. And we can have a discussion in the question session in this session, or we can just approach me for coffee later or send me. So one problem is obviously with the optical character recognition by using Tesseract with the bundles models for German and French. We still see quite a lot of noise being introduced, and we basically have little experience working with German and French, mostly English in our past professional lives. So we were wondering whether obviously there are companies here in the audience, what kind of OCR solutions would you recommend for German and French? Also, another question is how do you cope with all the OCR noise as you're basically doing feature extraction for the machine learning step? Another question that we have is related to the document format handling. We're basically using open source Apache Tika. And what we observed is that it's very hard to discern in many cases after the Tika runs what are the document segments, and all the table features get mixed up. There's parts of the table that go elsewhere and get mixed in between text and so on. What are recommended approaches to basically recover all these document segments and tables after you run a tool like Tika? Or is there something better that handles PDF from the start? Then another question regards the shallow NLP pipeline. I said we were using Stanford Core NLP with German and French language models. Apparently, or we found out that Core NLP lacks components for German and French, mainly the lemmatizer. And we would be interested from the audience to get recommendations on NLP solutions for German and French. In terms of event detection, so I said to you that the document offer relationship is end-to-end. So in this case, an event is kind of a variant of an offer. And these variants arise from either different documents or different sections of the documents, or even within the same paragraphs you have the event expressed for the first event, the information, and then later in that same paragraph, the information for the second event. And all of this is handled right now with some heuristics. Is there a principled way in which we can deal with potentially cross-document events? So the arisal of different variants of the base offer in the text. Then there are, as you might expect, problems related to obtaining labeled data. We have this database of past offers that I was telling you about, and essentially what they contain is for each offer the 56 fields filled in with their normalized value. Basically, you could think of it as a sort of the constant, right? And now you want to train machine learning, and you want to get labels for training this guy here, just based on the concept level that you get as a ground truth here. So in the text, many different surface forms of that concept can occur. What we're doing right now is we're basically taking literally that concept and finding occurrences in the text, producing a lot of false positives that the humans have to go through and check and signal in order to derive a classifier for entity extraction. We were wondering whether there is a better way. In terms of annotation, very practically, we basically have built a custom UI with annotation capabilities in it. This is costly, and it seems like we are always reinventing the wheel. Is there any recommendation from the audience regarding web-based component that can be just taken and integrated into a custom web app that we can use internally inside the company network, like the Mobiliar? So we heard about IBM's Butz solution for annotation, but that feels a bit too big and another environment to impose on the user. We need like a component that you add into some web app that is custom built by us. In terms of machine learning model, we're doing something very simple right now. For entity extraction, we're just basically sliding a window over the text, gathering the shallow NLP features as features that get extracted into the feature space. The center of the window basically has the label, the start of an entity or end of an entity. And we expect something around tuning the classifier for high precision, relatively okay recall. We expect something around 90% precision, 60% recall. And from the audience, is there anyone who would expect that by using more than shallow NLP features, such as bar trees, that very practically with your actual experience, would this help? Sequence labeling, like conditional random fields, would this help? And deep learning, would this help? But like from a practical perspective, not like we don't have time to be trying lots of stuff. All right, so just wrapping up. With this talk, there was two goals in mind. One is to give you a flavor or a feel that in the insurance industry that there's a number of use cases that are ripe for text mining, analysis of complex documents, policies, claims, and in this case regulations. And the Mobiliar, and I'm sure many other insurance companies are looking to get operational efficiencies through this kind of technology. As I hope that this talk illustrates the complexity of such solution can get very high relatively quickly. And I would basically appreciate what your feedback on these problems that we currently have. So feel free to email me or approach me during the meeting. Thank you.
We have time for questions. Any comments and similar experiences with the
I have a comment. So for the first problem, the OCR, I have a very simple solution.
Okay.
Just ask your clients to give you a machine-readable PDF of their regulations. That can't be so hard. No, but maybe, so I'm a journalist, so I have to OCR legal documents or documents coming from a federal agency. And my experience is that, unfortunately, open source tools are really bad at this at the moment. So what I've used, for example, is Adobe Acrobat Professional. It's hard to automate, but if you have 100 or 1,000 PDFs, you could do it by hand.
Yeah, and that works well.
That works very well.
Okay.
Better than Testra, way better.
Thank you.
Maybe also another simple solution, but just I would cluster up the words that you have, and then somehow I cluster, for example, like what did I cluster? I cluster 40 million words, and some of the OCR errors actually show up and form clusters together. So if you just run the words through cluster, and then you run the words through like a German and a French dictionary, then you get whatever that doesn't fall through the language.
Yep.
I think for the document format handling, we did a project on segmentation of newspapers, and we used deep learning for a visual approach. We could just take an image of a newspaper and it detects the boundaries of images and tables and stuff like that. It works pretty well. So, but you need a lot of examples, at least text documents. Not labeled, but you need them.
Okay. We don't have so many examples, maybe about the tower or so.
Okay.
So your solution is
with
not
30
portable.
pages, so it's 30,000.
Correct. Yeah. But your solution is not portable across the network. What you're saying?
It's a project with a partner, and we have to check whether they want to do it.
More comments, questions? Okay, then let's thank Jose again.
Thank you.